Good morning, students. Jai Swaminarayan. Welcome to our first video lecture of chapter 7. Now, students, we have already discussed almost all the theories of chapter 7. So now, today, students, we are going to discuss section D. The first question is, explain the meaning of population inquiry and sample inquiry with an illustration. Section D, students. Exercise 7. Answer 1. Now, students, here I am going to explain you, and then you have to write the answers on your own on the basis of explanation, students. This is the best possible explanation for theory. Now, students, all of you please concentrate. Section D, explain the meaning of population inquiry and sample inquiry with an illustration. Now, students, what is the definition of population inquiry? All of you know. Students, all of you know what is the definition of population inquiry. An inquiry in which each and every unit of the population is studied or inquired is called a population inquiry or census inquiry. The best example, a new class teacher asking each and every child about their names and hobbies. And this inquiry becomes students' population inquiry. So what is the definition of population inquiry? Once again, students, an inquiry in which each and every unit of the population is studied or inquired, students, is called a population inquiry or census inquiry. Then, students, the example I told, a new class teacher asking each and every child about his or her name and hobbies. Then what is a sample inquiry, students? Define sample inquiry. Next definition, students. Define sample inquiry. An inquiry in which only sample units, an inquiry in which only sample units are studied or inquired, students, is called a sample inquiry. Say the best example, a group of 5 students selected from a class of 60 students for a drawing competition who are good at drawing. A group of 5 students selected from a class of say 55 or 60 students, whatever you want to write, for a drawing competition. So this is what are the definitions of students' population inquiry, sample inquiry. You can also write population inquiry is also called census inquiry, and sample inquiry is also called, you can say, sample survey. Population inquiry is also called census survey. Population inquiry is also called census survey, and this is also called sample survey. This is also called sample survey. Next question is, differentiate population inquiry and sample inquiry. Next is, students, to differentiate population inquiry and sample inquiry. Okay, students, answer number 2 of section D. Students, first point is to write the definition. What is population inquiry? An inquiry in which each and every unit of the population is studied or inquired is called population inquiry. On the right hand side, you may write sample inquiry, an inquiry in which only sample units, an inquiry in which only sample units are studied or inquired, students, is called a sample inquiry. Second point, population inquiry involves more time, money and energy. Sample inquiry involves less time, money and energy. Then, in population inquiry, there are more chances, there is more probability of making mistakes as large number of units are to be studied. In sample inquiry, the probability or chance to make errors is less as we inquire smaller number of units. Then you can say population inquiry is not possible when the units are to be studied by destruction. Sample inquiry is possible when the units are to be studied by destruction. The best example, breaking of glass. The glass which is used to manufacture a bulb, then in such condition I have to break the glass to check the quality of glass. In such a case, students, we cannot have population inquiry. We cannot destroy the entire lot of bulbs which are prepared. So you can say these are basic points. Then you can say we have already written that population inquiry is time consuming, have more cost and it is not possible. Then you can say example. The next point is students' example. The best example, say a new class teacher asking students about their hobbies and names, and sample inquiry. You can say a group of 5 students which are to be, you can say, selected for a drawing competition are only called for their skills in drawing. So in general, students, we have to write only 5 points, and writing 5 points will be more than sufficient. First point, definition, that I am not repeating. Second point, population inquiry involves more time, money and energy. Sample inquiry involves less time, money and energy. Third point, population inquiry is not feasible when the units or inquiry is undertaken by destruction. Sample inquiry is feasible when the inquiry is to be undertaken by destruction or destroying the units. And you can say fourth point, population inquiry has more probability or chance of errors as large number of units are to be studied or inquired. Sample inquiry has less possibility or probability of errors as less number of units are to be studied or inquired. And then students, you can write one example. This is more than sufficient, students. Now the remaining questions, state the characteristics of an ideal sample. Students, we have already discussed, we have to write as given in textbook, we cannot change it. Then state the points to be considered by determining the sample point. Those 4 points are there, students, we have already discussed, we have to write as it is. Then state the advantages of simple random sampling. Students, have already discussed. Then students, write a short note on simple random sampling method. Students, pay attention. A short note on simple random sampling and short note on stratified random sampling. These are very, very long short notes. Students, in simple random sampling, first we have to write the definition of a simple random sampling. Then students, we have to say that in simple random sampling we have 2 methods. The first is lottery method and the second is method of random numbers table. So that long short note you avoid, students, that we will not ask in exam. But do remember, we can ask you the short note on lottery method individually, and we can ask you the short note on method of random numbers table. But entire short note on simple random sampling we will not ask because it is a very, very long short note. But you have to remember, students, lottery method and method of random numbers table. Then students, write a short note on stratified random sampling. Already, students, you can say discussed stratified random sampling. Once again, if you want, we can revise it in nutshell. Stratified random sampling method is used when the population is heterogeneous. When the population is heterogeneous, simple random sampling is not useful. The process of dividing heterogeneous population into homogeneous group is called stratification, and each such group, students, is called strata. Then, when we select certain units from each strata, few certain sample units are selected strata-wise, and the collective sample which is formed is called stratified random sample. The method of selecting stratified random sample is called stratified random sampling method. How many units to select from each strata? We have strategies like, you can say, proportional allocation, means units from strata are to be selected based on strata size. Optimal allocation means certain minimum number of units from each strata, and cost minimization. Next are the strategies used to select units from each strata. So students, we have to, you can say, write this in the short note, and even you have to add advantages and disadvantages, then only the short note is completed. But as such, it is a very long short note. Then students, 9. Write a short note on systematic sampling. In systematic sampling, the first unit is selected at random based on sampling interval, and thereafter, students, the units are selected in definite order. The first unit is selected at random based on sampling interval, and thereafter the units are selected at random. Then, in this method, we need to have a complete list of units of population. In this method, students, we have to have a complete list of the units of population, and then you can say we will select the sample units based on sampling interval. Sampling interval is the ratio of population size to sample size, and k is an integer. All these things, students, we have already discussed. Then advantages and disadvantages of, you can say, simple random sampling or systematic sampling we have done. Why is population inquiry usually not feasible in practice, students? Answer 11 is very, you can say, interesting. Why the population inquiry is usually not feasible in practice, students? Population inquiry involves more time, money, and energy. Population inquiry is not feasible when the units of population are spread over a wide geographical area. Even population inquiry is not feasible when the units are to be studied by destruction. And population inquiry always involves or has a high chance of errors in practice. So while population inquiry is not feasible in practice, students, population inquiry involves more time, money, energy. More number of expert enumerators are involved, so cost increases. And as large number of units are to be studied in a population inquiry, there is more chance of, you can say, errors in population inquiry. That is why population inquiry is not feasible in practice. Still, the advantages of sampling. Means why sampling is used in day-to-day life. Sampling or sample inquiry involves less time, money, and energy. Sampling is very useful when the number of units in the population are very large. Sampling is inevitable in day-to-day life as population inquiry is not practically possible, and sampling involves less time, money, and energy. Less number of expert enumerators are required in sampling. And based on sample data, sample statistics such as mean, median, mode, standard deviation can be also easily calculated. Calculation of population parameters is a very difficult, tedious, and time-consuming job, students. This is how we have to understand the advantages of sampling, students. So, students, this is highly theoretical chapter. Students, this is highly a chapter which is theoretical, and one must very carefully, students, understand understand the logic which is used in this particular chapter. Now students pay attention. Today I am not going to do all the sums. First of all, students, I want to do the sums of systematic sampling. Students, today we are not going to do all the type of sums in one lecture. The easiest sum, as such all sums are easy, students. You will not worry. But today, students, the first target is to do the sums of systematic sampling. Students, please pay attention. At present, I am not doing question 13 to 17. We are, you can say, doing sum number 18, 19, 21st. Next students, we will do, you can say, the remaining sums. First of all, in systematic sampling, sums of systematic sampling. In systematic sampling, the formula which we will remember is K is equal to capital N 1 small n. In systematic sampling, the formula, students, which we have to remember, the formula, students, which we have to memorize is only one, where K is the sampling interval, N is size of population, and small n is sample size. And always remember, K is equal to sampling interval, which is always an integer. Means you can be very 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Positive integer. Starting from 1 to any value within the range of say 15 to 20. You will never have sampling interval more than 20 in practice. Students, while I am emphasizing first on the sums of systematic sampling, again I am reiterating the most important types of sums are the sums of systematic sampling, which are useful in advanced statistics. So at present we are starting from sum number 18 and we will complete questions 18, 19 and 20. There are 60 employees in the office of an IT company. So population size is 60. So we are according to capital N 60. This is size of population. These students, we have already studied in chapter 1. Size of population is denoted by capital N. And size of sample is denoted by small n. Then 5 employees are to be selected using systematic random sampling for a trial of work from home concept. Explain how can sample be selected. A sample of 5 employees. So sample size is, students, n is equal to 5. In this type of sum, students, first of all we must understand and collect the data, and after data collection, students, we should start the sum. So we have a population of 60 employees in the office of an IT company. 5 employees are to be selected using systematic random sampling for a trial of work from home concept. Explain how can a sample be selected. Now students, we will find sampling interval. First of all, students, we will find sampling interval K is equal to capital N divided by small n, 60 divided by 5, that is 60 divided by 5, and that is 12. Now students, what I will do? I have to select a sample of 5. My first unit will be the 12th. Then at a gap of 12, so second unit can be 24, 36, 48 and 60. This 5 can be my possible sample. So always, whenever students we are doing some sort of systematic sampling, first of all, collect the data of population size and second, sample size. According to given, capital N is 60, small n is 5. So sampling interval K will be capital N divided by small n, 60 divided by 5, so 12. Now in systematic sampling, students, according to the theory or definition, we need a total units of list of total units of population from 1 to 60. So the first unit will be the 12th unit. Then at a gap of 12, 12 is a 24, 12 is a 36, 12 is a 48, 12 is a 60. This can be a possible sample. So this is how, students, we select a sample in systematic sampling. Even we can select the first unit at random, students, and then students we can select at a gap of certain units. Then also, students, we can do. So we can randomly select. It is not that, students, we have to select 12th unit. I can randomly select. We can randomly select one unit from 1 to 12. This is only one possibility, students. This is one of the possibilities. One possibility. This sampling interval 12 actually, students, indicates that we can select randomly any one unit from the first 12 units. But what I thought, that if I select 12th unit, then afterwards I will select 24th unit, then afterwards I will select 36th unit, then afterwards I will select 48th unit, afterwards I will select 60th unit. Suppose, students, I select 8th unit. We are free to select any one of the unit from 1 to 12. Even I can take 12 also. So if I take 12th unit, then 24, 36, 48, 60. Suppose I have taken 8th unit, then at a gap of 12, 8 plus 12, 28. 20 plus 12, 32nd. Like this also, students, we can select. Then 32. Then again I add 12. 32 plus 12. 44 and plus 12. So I can even take 56. This can be also my sample units. Whenever you have a sample interval K, you can select any one unit from 1 to 12. So this was the possibility when I took the 12th unit, which is the easiest way. The easiest way, take the first unit as 12, then at a gap of 12, so 24, 36, 48 and 60. Suppose I take 8, then at a gap of 12, 8 plus 12, 20 plus 12, 32 plus 12, 44 plus 12, 56. Suppose I would have taken 5th unit, then 5 plus 12, second unit will be 70. Then 17 plus 12, 29. But gap should be 12. Any one of the unit from first 12 unit, but students, the gap should be definitely of 12. You cannot have more gap than 12. So this is the second possibility. There are multiple answers. This is second way. Isn't it? So I hope all of you understood. We are free to select any one of the unit from first 12 unit, but gap must be 12. So this is first possibility, second I told. If I take 5, then at a gap of 12, so the third possibility will be like this. Third way. The third way would be like this. Suppose if I take 5th, then add 12. 5 plus 12, 17. 17 plus 12, 29. 29 plus 12, 41. 41 plus 12. So 50. Like this also students I can take. Gap must be 12 and we can randomly select any one of the 12 units. So you have multiple possibilities. If I take 4, then 4 plus 12, 16. 16 plus 12, 28. 28 plus 12, 40. And 40 plus 12, 52nd. And that also. So here students we have multiple ways. Now students I am doing sum number 19. Now students I am doing sum number 19. Select all possible samples of size 4 using systematic sampling from a population of 20 units. Okay, sum number 19. According to given n is equal to 20, small n is equal to 4. So first of all we find sampling interval k is equal to capital N over small n, 20 divided by 4. So I have 5. So gap should be 5. And I am free to select any one of the units from first 5. Gap is 5. And students, I am free to select any one of the units from 5. So possible samples will be 5. If sampling interval is 12, possible samples will be 12. If sampling interval is 5, possible samples will be 5. So I had sample 1, S1, S2, S3, S4 and S5. In the previous one we had sampling interval 12. So students, the possible samples will be 12. Now suppose I start with first unit. I select first unit, then at a gap of 5. 1 plus 5, 6, 6 plus 5, 11, 11 plus 5, 16. Isn't it students? And you can say we have to select a sample of how many units, and the answer is 4. So only 4 units. Clear. Now suppose I take second, then at a gap of 5, so 2 plus 5, 7, 7 plus 5, 12, 12 plus 5, 7. So the second sample is 2, 7, 12, 17. Suppose I take third unit from first 5, then at a gap of 5, 8, 30, 8. Suppose I take 4, then 9, 40, and 19. Suppose I take 5, then 10, then 50, 20. So these are 5 samples of size 4. Whenever we get sampling interval 5, it means we are free to select first unit from 1 to 5. Check. 1, 2, 3, 4, 5. Suppose my sampling interval was 10. I am free to select any one unit from first 10. Suppose my sampling interval is 20. Then I am free to select any one unit from 20. So according to the sampling interval, which is 5, these are the possible 5 samples. Okay, so sum number 20. The last sum of systematic sampling. Still, you are free to ask me if you have any doubts. A teacher wants to take homework of 10 students out of 30 students of standard 11th of school. How many random samples can you obtain using systematic sampling? Check homework of 10 students. Okay. Let us do sum number 20. According to given, capital N is 30, small n is 10, sampling interval is 3. So how many samples are possible? 3. So write like this. S1, S2, S3. Suppose this was 5, then 5 samples, 10, then 10 samples. Now the first unit is selected from first 3 units. So let us take 1. Then in a gap of 3, 1 plus 3, 4, 4 plus 3, 7, 7 plus 3, 10, 10 plus 3, 30, 30 plus 3, 60, plus 3, 90, plus 3, 22, plus 3, 25, plus 3, 28. Then I select first plus second, 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, 11, 11 plus 3, 14 plus 3, 17, 20, 23, 26, and 29. Suppose I take third unit, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Number of possible samples to this will be according to the sampling interval. If sampling interval was 5, there are 5 possibilities for sample like that. We have to write. So this is going to be very easy, students, once you understand. If sampling interval is 3, I am free to select first unit from any 3 integers. If my sampling interval is 5, I am free to select first unit from 1 to 5. If my sampling interval is 10, I am free to select first unit from 1 to 10. If my sampling interval is 12, I am free to select my first unit from 1 to 12, like that it is. So, in the 18 substitutes, we had a lot of possibility. As your sampling interval was 12, we have 12 possibilities for sampling. Number of possibilities will coincide with sampling interval. Number of samples or number of possibilities, students, will coincide with sampling interval. So this is very easy, very interesting, students. So please try to understand and do the sums twice. The remaining questions, that is students, questions 13 to 17, we will complete in the next lecture and complete the chapter. Okay students, so we conclude the lecture. I will see you in the next lecture.